This is our third lecture. We are going to explain the third chapter, which is powers and radicals. The objectives are to define the square root and the nth root of a positive real number, to express a positive number in scientific notation. We are going to rationalize the denominator of a fractional expression and solve equations with powers. Powers having natural exponents. So the product of a times a is a to the power 2 or a exponent 2. The product of a times a times a is a to the power 3. Then product of a times n number of a, it's a to the power of n. By convention, a to the power 1 is a and a to the power 0 is 1. And a to the power minus n is 1 over a to the power n. Minus 1 to the power n. If n is even, then it's 1. If n is odd, it's minus 1. Powers having rational and irrational exponent. N radical a is a to the power 1 over n, where a is non-negative number and n can be any index. Example, radical 7 is 7 to the power half, and b to the power 1 over 3 is 3 radical b. 15 to the power half is radical 15, and whatever you have inside the radical, you write it 1 over 3, because you can write this, all of it, to the power of 1. For any non-negative number, so this is the general rule, n radical a to the power m is a m to the power of m over n, a to the power of m over n. So the inside power over the outside index. Example, b to the power 2 over 3 is written as 3 radical b to the power 2. And whatever you have inside this bracket, you just look at the power. 7 is inside and 3 is outside. A quick revision for the properties of powers. A to the power n times a to the power n, you add the powers. An to brackets m, you multiply the powers. Am over an is a, m minus n, you subtract the powers. And if you have the same power and different base, you multiply the base with the same exponent. Sign of the power of a negative and a positive number. If a is positive, then a to the power n is positive. If a is negative, then if n is negative, a is negative. If n is even, you will get a positive number. If n is odd, a to the power of n is negative. So if it's even power, you will make the number positive. If the n is odd, you will make the number negative. Scientific notation. Scientific notation of a decimal number is in the form of a times 10 to the power n, where a is any number between 1 and 10, and n should be always an integer number. Example 0.0314 is written as 3.14 times 10 to the power minus 2. So only one digit point something, and the power should be integer. Another example, 134.72 is written as 1.3472 times 10 to the power minus 2. the square root of a real number. If I have x squared equals a, then x equals radical a and x equals minus radical a. So you will get two solutions. But if a equals to 0, x to the power 2 equals 0, it's only one solution, which is x equal to 0. If a is negative, then no solution, because the square root of a number could never be negative. Example: find if possible the values of x. As x squared equals 25, let us see the following. X squared minus 25 equal to 0. You will see that I'm going to solve two of them. X squared equals 25, then x equal plus or minus 5. The second one, x squared equals minus 9. This is impossible. Okay? Let us look at some properties of the square root. You know that radical a times radical b equals radical a times b. Radical a to the power n is radical a n. Radical a over radical b is radical a over b. And radical a squared equals absolute a. If a is positive, then a. If a is negative, then minus a. Remark that radical a plus radical b can never be radical a plus b. Let us rationalize. If I have 2 over radical 3, you know that I multiply by the denominator, which is radical 3. So I get 2 radical 3 over 3 with no radical in the denominator. Now, if I have radical 3 plus 5 in the denominator, I multiply by the conjugate of radical 3 plus 5, which is radical 3 minus 5. And you calculate. About calculation, you will see that in the denominator there's no more radical. Now, what if I have nth root? So 1 over 5 radical 2. I multiply by 5 radical 2 to the power 4. So every time you should write 1 less than the index. Why? Because when you multiply those two, you are going to add the power inside, and whenever you add the power inside, you will get 5, and now 5 over 5, you will get 2 with no radical. So this is the only way. So if you have here 1, you write 1 power less. Okay? Now we call nth root of a any real number x, such that x to the power n equals a. If n is odd and a is any real number, you can write that x equals n radical a. Example, x cubed equals minus 8, then x equals 3 to the radical minus 8, or in another word, you write the 8 as prime number, which is 2 to the power 3, and then it's minus 2. This is if n is odd. Another example, x to the power 5 equals minus 32. You write, how can you get rid of the 5? You multiply both of them by radical 5 in this case. So for this one, you are going to get only x, and in this one, you are going to write the 32 as a prime factorization 2 to the power 5, and then you will get rid of the nth root, and the answer is minus 2. Now, properties. N radical a and radical b equals n radical ab. So if you have the same nth root, n radical A over n radical B is n for both A over B. Example, if you have 4 radical 48 and 4 radical 3, it's 4 radical 48 over 3, and 48 over 3 is 16, and you know that 16 is 2 to the power 4, so the answer is 2. Example for the second property, if you have 3 radical minus 27, you know that the 27 is 3 cubed, so you will get rid of the following, and the answer is minus 3.